Imagine for a second that you are walking into your local grocery store. You've got a list, you're on a mission, and you just want to buy like a simple bag of apples.
Right, just a basic errand.
Exactly. But the moment you walk through those automatic sliding doors, you realize this particular grocery store is laid out like an absolute madhouse. The apples aren't just sitting in the produce section with a clear price tag.
That would be too easy.
Way too easy. Instead, half of the apples are sitting over in aisle 3. And they're priced based on this highly specific, constantly updating ledger of what every single other customer in the store is willing to pay for an apple at that exact millisecond.
It sounds exhausting already.
Oh, it gets worse. If you want one, you have to write your name on a piece of paper, write down your bid, pin it to a corkboard, and, wait for a farmer to walk by and agree to your specific price.
Which is already a logistical nightmare if you're just trying to make a pie.
Right. But the other half of the exact same batch of apples is all the way over in aisle 12. And they're floating in this giant, opaque plastic bin filled with both apples and oranges.
The classic liquidity pool.
Yep. And the price of the apples in this bin changes automatically based on a really complex mathematical formula calculating the ratio of apples to oranges left in the water.
So you pull an apple out, and the remaining apples instantly get more expensive.
Exactly. Now, you want the best price, obviously. Everyone does. But to get it, you have to literally sprint back and forth between aisle 3 and aisle 12.
Doing complex mental math on the fly.
Totally. You're trying to figure out which system is going to give you the better deal before someone else swoops in and buys them. And if you're making a massive pie and need a lot of apples...
You're going to wreck the market.
Yeah. You might have to buy a few in aisle 3, watch the price spike because you cleared out the cheap ones, sprint over to aisle 12 to buy the rest from the bin. It's ridiculous. By the time you're done, you're exhausted, you've paid 3 different prices, and you have a massive headache.
It sounds like a grocery store that would, frankly, go out of business in a single afternoon.
It really does.
It sounds like a psychological experiment designed to break the human spirit. And yet, this is the accepted, standard operating procedure for a multi-billion-dollar financial industry.
That is the wild part to me. If you're trading digital assets right now, this is exactly how decentralized finance, DeFi, currently works. You are the person sprinting between the aisles, clutching your wallet, trying to beat the math.
It's completely fragmented.
It is. Okay, let's unpack this. Today on our deep dive, we are exploring the architecture of the newly launched CLOAK Hybrid DEX on the Telos mainnet.
A really fascinating project.
It is. Our mission today is to understand how this platform is attempting to completely rewrite the rules of decentralized trading for you. We're looking at a system that claims to take all that fragmentation, all that running back and forth, and eliminate it entirely.
That is the monumental ambition we're analyzing
Wow.
today, yeah. Set the stage a bit. CLOAK has officially launched its first trading pair, the CLOAK to TLOS market.
Right.
And their stated mission is to solve DeFi's long-standing, just seemingly intractable issue of fragmented liquidity. They're doing this by merging 2 completely different trading models.
The 2 aisles in our grocery store.
Exactly. Traditional order books, which is your corkboard in aisle 3, and automated market makers, or AMMs, which is your giant bin in aisle 12. They're bringing them into one unified system.
And doing it with native privacy too, right?
Yes. Native privacy built directly into the base layer, which we will definitely get into.
It's a massive architectural shift. But before we get into the shiny new mechanics of CLOAK, I think we have to understand the structural flaw they're trying to fix. Because right now, the state of DeFi is fundamentally broken.
It really is.
Let's talk about the great divide in DeFi. How did we even end up with 2 different aisles in the first place? I mean, if traditional finance just uses order books like the New York Stock Exchange, why did crypto invent the giant bin of apples?
Well, it comes down to the limitations of early blockchain technology. In traditional finance, centralized exchanges use a limit order book, or LOB.
Corkboard.
Right. It's a very simple concept. Buyers list the maximum price they'll pay. Sellers list the minimum price they'll accept. The exchange's computer simply matches them up.
Sounds easy enough.
It is, but the problem is updating that ledger requires thousands of calculations per second. People are constantly placing orders, canceling orders, tweaking their prices by, a fraction of a cent.
Which is easy for a centralized server in New Jersey to handle, but terrible for a global blockchain.
Precisely. In the early days of Ethereum, every single transaction cost gas a network fee. And a block was only mined, like every 15 seconds.
Oh, yeah.
So if you wanted to build a decentralized exchange on-chain using an order book, Every time a trader wanted to simply cancel an order or change their bid, they had to pay a network fee and wait 15 seconds for it to register.
That sounds incredibly
It
painful.
was economically unviable. The order books were slow, expensive, and frankly, mostly empty.
So the industry had to invent a workaround, and that workaround was the automated market maker, the AMM.
Exactly. AMMs were a brilliant innovation born out of pure necessity. Instead of a peer-to-peer system where a buyer matches with a seller, an AMM is peer-to-pool.
The giant bin of fruit?
Yes. Users lock their tokens into a smart contract, a liquidity pool. There is no order book, there are no bids or asks,
Just math.
just a mathematical formula. Usually, X times Y equals K. That determines the price of the asset based purely on the ratio of tokens in the pool. It requires very little computational power.
So you just send your trade to the pool, the math updates, and you get your tokens. It's like a robot holding a bucket. You throw $1 in, it throws a token out, and it adjusts the price tag for the next guy automatically.
That's a great way to look at it.
But here is the problem. While AMMs solve the computational issue, they created a massive market efficiency issue because suddenly the liquidity, the actual capital available to facilitate trades, became artificially divided.
And that is the chasm we face today. Over the years, blockchains got faster, right? So developers started building on-chain order books again.
Because they finally could.
Right. But the AMMs didn't go away. So now you have one set of liquidity locked in AMM smart contracts and an entirely different set of liquidity sitting on limit order books.
In completely different systems.
Yes, they use different routing logic. A smart contract interacting with an order book has to behave fundamentally differently than one interacting with an AMM.
It's like having your life savings split between two banks that absolutely refuse to talk to each other. Say you have a checking account at Bank A and a checking account at Bank B. You need to send a wire transfer to buy a house. But to figure out which bank has the better exchange rate, you have to log into both, compare them, maybe move money between them, paying fees along the way, just to execute a basic financial function.
And the result is deep fragmentation.
Mm-hmm.
It creates massive inefficiencies. But most importantly, it shifts the burden of market efficiency onto you, the user.
Right, the user has to do all the heavy lifting.
Exactly. You are forced to adapt to the protocol's rigid structure, rather than the protocol adapting to your simple desire to trade an asset.
But wait, let me push back on this a little bit. Is this really a deep-rooted architectural flaw? Because, I use decentralized exchanges all the time, and I don't feel like I'm running between aisles.
You don't.
No, I use aggregators. I go to a pretty website, I type in what I want to swap, and it searches all the different DEXs for me. Doesn't that solve the problem? Why tear down the whole system if we already have search engines for liquidity?
Because aggregators are just slapping a Band-Aid on a broken bone.
A Band-Aid.
Yes. An aggregator hides the mess from your eyes, but the mess still exists on the blockchain. The aggregator is an external tool trying to herd cats. The liquidity is still physically separated in different smart contracts.
So what does that actually mean for my trade behind the scenes?
It means the aggregator has to route your trade through complex, multi-step pathways. If you want to buy, say, $50,000 worth of a token, the aggregator might buy $10,000 from an AMM on protocol A,
Okay.
then $20,000 from an order book on protocol B, and the rest from another AMM on protocol C. To execute that single intent, the aggregator has to interact with 3 separate smart contracts.
Oh, and I assume I'm paying for all of that.
You are. You're paying 3 separate sets of gas fees and navigating 3 separate points of failure. If one of those protocols experiences a sudden price shift while your transaction is processing, your entire trade can fail. Or you can get hit with terrible slippage.
Ah, so I'm paying a premium for the illusion of a unified market. The friction is still there. It's just being baked into my transaction costs and my execution risk.
Exactly. Aggregators optimize the fragmented reality, but they don't fix it. The ambition of CLOAK isn't to build a better aggregator.
They want to fix the root cause.
Right. Their ambition is to completely redesign the underlying architecture so the fragmentation doesn't exist in the first place. They're building a new foundation where the order book and the automated pool are native to one another.
So instead of building a bridge between the two banks, they are tearing down both banks and building one massive, unified financial institution from the ground up.
That's the vision.
Which brings us to what CLOAK calls the one market, one price revolution. If the problem is that these two systems stubbornly refuse to communicate, how exactly does CLOAK mechanically force them to integrate?
They do it by moving the integration down to the very core of the decentralized exchange itself. CLOAK combines order book liquidity, the precise limit orders, and AMM liquidity into a single unified market.
But don't other platforms do that?
In most DeFi platforms, even if a project offers both an order book and an AMM, they don't truly integrate them. They live in different tabs on the website. They're siloed. CLOAK merges them at the execution layer.
Okay, merging at the execution layer sounds great in a white paper, but let's get into the weeds. How does that actually work when I click buy?
Sure, let's trace it.
Walk me through the exact microsecond path of my digital dollar. If I submit an order to buy $10,000 worth of TLOS, what does this execution engine actually do?
You submit a market order. Instantly, the CLOAK execution engine looks at the unified market. It doesn't see two separate pools. It sees a single landscape of available liquidity.
Okay.
The engine executes a strict deterministic if-then logic sequence to hunt for the absolute best price.
What's step one?
Step 1. The engine evaluates the order book. Let's say there is a seller sitting there who has placed a limit order, explicitly offering to sell TLOS at 15 cents.
Okay, a human setting a firm price.
Right? If 15 cents is mathematically the best possible price across the entire ecosystem at that exact millisecond, your trade executes against that limit order.
Makes perfect sense. It checks the traditional ledger first. If someone is offering a hard fixed price that beats the robot bucket, take the human's offer.
Correct. But let's say the order book is thin. Maybe the next limit order is asking for 16 cents. The engine instantly checks the AMM.
That's step two.
Step 2. If the mathematical curve of the AMM pool dictates that it can sell you TLOS for 15.5 cents, the engine dynamically ignores the 16-cent limit order and seamlessly flows your trade into the automated pool.
So it's actively hunting. It's slicing the order up based on whatever mechanism offers the cheapest fraction of a penny.
And it gets even more sophisticated than that. What if your $10,000 order is so massive for this specific market that it eats up all the good prices on the order book and it eats up all the reasonable prices in the AMM?
And filling the rest of the order would cause massive slippage, meaning I'd be overpaying wildly for the back half of my trade.
Right, which happens all the time on standard AMMs. You place a big order, and by the end of it, you're paying 10% above market value just because you drained the pool.
It's the worst feeling. So what does CLOAK do?
Step 3 of CLOAK's logic kicks in. If there is remaining unfilled volume from your trade and executing it immediately would result in an unacceptable price impact, the engine can automatically convert that leftover volume into a limit order.
Wait, really? It just parks the rest of my money?
Yes, it takes the rest of your money, pins it to the order book at a specific fair price, and waits for the market to come to it.
So what does this all mean for you, the listener? It means a complete cessation of operational complexity. You don't have to be a part-time quantitative analyst just to swap some tokens.
Exactly.
There is no manual decision-making required. You don't care if the liquidity comes from an AMM or an order book. The exchange acts as a unified environment obsessed strictly with one thing: best execution.
It does the heavy lifting for you.
It is doing the sprinting between aisle 3 and aisle 12 for you at the speed of light while you just stand at the cash register.
You are outsourcing the complexity of market structure back to the protocol. The user should merely express intent. I want to trade X for Y. And the protocol's architecture should be sophisticated enough to figure out the most mathematically efficient way to fulfill that intent.
Now, having a single market is a beautiful theory, but this is where I need to really challenge the mechanics. Because integrating a discrete order book, which is just a list of hard numbers, with a continuous AMM mathematical curve, sounds like you're mashing two totally different calculators together and praying they don't explode.
It is a massive technical challenge, yes.
Let's dig into the math of what they call the unified liquidity curve, because this is where the trader actually saves money.
This is undoubtedly the most elegant piece of engineering in the system. Within CLOAK, they aren't just mashing a basic order book and a basic AMM together. They are unifying three different types of liquidity. Yes. Limit orders, constant product liquidity, and concentrated liquidity.
Okay, hold on. We need to define those last two. Those are dense technical terms that get thrown around a lot in DeFi circles, but we need to break them down. Constant product liquidity versus concentrated liquidity. What is the difference?
Let's start with constant product. This is the original primitive AMM model. Think of Uniswap v2.
Okay.
You are a liquidity provider. You deposit equal values of two tokens, say $1,000 of CLOAK and $1,000 of TLS into a pool. The smart contract uses a very simple formula: X times Y equals K. The product of the two token balances must always remain constant.
Right, so if I buy TLOS from the pool, I am removing TLOS and adding CLOAK. The ratio changes, so the price of TLOS goes up.
Exactly. The brilliant thing about the constant product formula is that it ensures there's always liquidity available at any price point, from 0 to infinity.
Because it's an asymptote, right?
Yes. As the pool gets drained of one token, the price of that token approaches infinity, meaning the pool will never theoretically run completely dry. It provides what we call unbreakable baseline depth.
It's the dependable workhorse of DeFi. But it's also incredibly inefficient, right? Because if my money is spread evenly along a price curve from 0 to infinity, 99% of my capital is sitting at extreme price points that will never actually be traded.
That's the main criticism, yeah.
I might have money sitting there waiting to sell TLOS at $1 million a token. It's dead capital.
Which is exactly why the industry evolved to concentrated liquidity. Think of Uniswap v3. Concentrated liquidity allows you, the provider, to set parameters.
So I get to choose where my money goes.
Yes, you can say, I don't want my money spread out from 0 to infinity. I only want my money to be used to facilitate trades when the price of TLOS is between 14 cents and 16 cents.
Because that's where the actual trading action is happening today. You're packing all your capital into a tight little band around the active market price.
Yes, it creates immense capital efficiency. $1,000 of concentrated liquidity can facilitate the same trading volume as $100,000 of constant product liquidity, provided the price stays within that chosen range.
So historically, protocols treat these as entirely separate pools. You have a constant product pool over here for the lazy capital and a concentrated pool over there for the active capital.
But CLOAK fundamentally alters this dynamic. They combine the constant product math and the concentrated liquidity math into a single unified price curve.
Really?
The constant product provides the unbreakable baseline depth, the safety net, while the concentrated liquidity provides intense efficiency right where the price currently is. And these two pools move in lockstep. They are evaluated by the execution engine as one continuous mathematical reality.
Let me try an analogy here. It's like having a river. The constant product liquidity is the deep, wide flow of the river itself. It guarantees that water will always be moving no matter how wide the banks get.
Okay, I like that.
But the concentrated liquidity is like installing a series of high-pressure jets right in the deep center channel where all the heavy cargo ships actually travel. It makes the active lane incredibly efficient without sacrificing the safety of the wider river.
That is an excellent visualization. But the true magic of this unified curve only becomes apparent when you introduce the third element back into the mix.
The limit orders from the order book.
Exactly. Because this is how Camboyle achieves the holy grail of trading, the death of the spread.
Okay, yes. Let's talk about the spread, because this translates directly to saving the user money. For anyone who doesn't stare at trading screens all day, what exactly is the spread, and why is it considered the enemy of the trader?
In any traditional market, there is a gap between the buyers and the sellers. Let's look at an order book. You have the highest price a buyer is willing to pay. That is the best bid. Let's say the best bid for a token is $9.90.
Okay.
Then you have the lowest price a seller is willing to accept. That is the best ask. Let's say the best ask is $10.10.
So the buyer won't pay a penny over $9.90, and the seller won't take a penny less than $10.10.
Exactly. The empty space between those two numbers, that 20-cent gap, is the spread. Nothing happens in that 20-cent gap. It is dead air.
It's just a void.
Right. If you're an impatient trader and you just want to buy immediately, you have to cross the spread. You have to accept the seller's higher price at $10.10. That 20 cents is value. You instantly lose the moment you execute the trade.
It's like the house cut in a casino. Or think of it like the dead zone in a relay race where the baton is passed. It's an area of pure friction where momentum stalls and value bleeds out of the system.
And in traditional finance, market makers make billions of dollars just pocketing that spread.
Exactly.
Yeah.
So how does CLOAK destroy it?
By using the continuous nature of the AMM. Remember, an order book is discrete. It is made of specific hard numbers. $9.90, $10.10. It leaves gaps. But the AMM is a continuous mathematical curve.
It doesn't have gaps.
None. It calculates a price for every conceivable fraction of a micropenny. In CLOAK's unified model, the AMM liquidity naturally flows into the empty space between the best bid and the best ask on the order book.
I see. So the order book is made of bricks hard limit orders, and the AMM acts like mortar, completely filling in the cracks between the bricks.
Exactly. Because the AMM is constantly offering a mathematically fair price right in the middle of that 20-cent dead zone, the spread essentially ceases to exist.
That's amazing.
The bid and the ask are bridged by the continuous liquidity curve. Price discovery becomes a fluid, unbroken line, rather than a series of jagged jumps from one limit order to the next. The spread shrinks dramatically, often approaching near zero.
But wait, if the AMM is acting as mortar, filling in all these highly active potholes between the bid and the ask, doesn't that require a terrifyingly sophisticated engine?
It absolutely does.
Because the order book is total chaos. People are adding and pulling limit orders every 100 milliseconds. Bots are spoofing orders. The AMM has to dance perfectly with that chaos without breaking its own mathematical formula. If it sequences a trade wrong, a bot could arbitrage the difference and drain the pool.
Which is exactly why this hasn't been successfully standardized until now. Integrating discrete human intent with a continuous mathematical curve requires an incredibly robust on-chain execution engine.
It has to be flawless.
It has to evaluate that lockstep movement instantly, with zero latency. If the engine stutters, the mortar cracks, and value is extracted by arbitrageurs.
But if they actually pull it off, it solves the biggest lie in crypto trading, the illusion of liquidity.
Oh, elaborate on that. The illusion of liquidity.
We've all seen it. You log into a standard DEX, you look at a token pair, and it says total value locked, $50 million. You think, amazing, this market is incredibly deep. I can sell $100,000 worth of my tokens easily.
Right.
But then you actually submit the trade. And because that $50 million is fragmented, or because it's lazy constant product liquidity spread out to infinity, your $100,000 trade absolutely crushes the active price band. You get hit with massive slippage. The paper reality of the TVL does not match the execution reality of the trade.
That is the exact friction CLOAK is targeting. By unifying the baseline depth, the concentrated efficiency, and the precise limit orders into a single gapeless curve, they create a density of liquidity that fights slippage aggressively.
It's all working together.
Yes.
Yeah.
The spread is gone, the gaps are filled, and your execution price finally matches the paper reality.
Okay, so we have this brilliantly engineered, unified liquidity curve. It's an absolute marvel of mathematics and routing logic. But I have to play devil's advocate here.
Go for it.
A brilliantly engineered V8 engine is completely useless if you don't put any gas in the tank. A mathematical curve means absolutely nothing if there is no actual money inside it when the door is open. So let's talk about the reality of the launch. How did CLOAK prevent the cold start problem, and how do they incentivize users to keep the engine running?
The cold start problem is the silent killer of decentralized protocols. The most dangerous time for any new trading pair is its genesis block. If you launch a DEX and the liquidity pool is empty, the first person who tries to trade is going to experience catastrophic volatility.
It's like opening a brand new commercial bank, but there is only $10 in the vault. The first customer who tries to withdraw $20 breaks the entire institution.
Precisely. If someone tries to buy even a small amount of a token in an empty pool, the AMM math causes the price to skyrocket vertically. If someone sells, it crashes to zero. Traders get burned on day one, the community loses faith, and the market never recovers.
So how did CLOAK handle it?
CLOAK addressed this directly with a bootstrapping mechanism tied to their token auction.
Break that down for me. How did the auction fuel the DEX?
Prior to launching the exchange, CLOAK conducted a token auction to distribute their native CLOAK tokens. Participants paid for these tokens using TLOS, the native asset of the TLOS network.
Okay.
Now, standard practice in crypto is that the team takes those auction proceeds, puts them in a treasury, and maybe uses them to pay developers or fund marketing.
Right. The classic thanks for the cash, we'll build something eventually model.
Exactly. But CLOAK modeled it differently. Approximately 15% of the TLOS proceeds generated from that auction were not pocketed or locked in a passive treasury. They were intentionally and mechanically injected directly into the initial constant product pool of the CLOAK market the moment it went live.
15% straight into the pool. Why is that specific injection so crucial?
It provided three immediate stabilizing advantages. First, immediate tradability. Users could buy and sell at market launch without facing a blank order book.
Huge.
Second, it established meaningful baseline depth. A 15% injection of total auction proceeds is a substantial buffer. It meant the pool could absorb normal early adopter trading volume without wild mathematical price swings. Third, it established a continuous fair price curve right out of the gate.
So they essentially seeded a mature market environment artificially to protect the early adopters from Genesis volatility. That's a very pragmatic piece of financial engineering. But that 15% is just the seed. To survive long-term, a DEX needs everyday users to constantly provide fresh capital. It needs market makers.
It does.
So what is the economic incentive for me, a normal user, to lock my valuable tokens in this platform?
The incentive is built into a fee structure that stands out precisely because of how utterly simple it is. The model is straightforward. The taker pays, the maker earns, and the protocol receives a nominal platform fee.
Okay, let's quickly define maker and taker for clarity.
Sure. A maker is someone who provides liquidity to the market. They make the market exist. If you place a limit order on the book that sits there waiting to be filled, or if you deposit your tokens into the AMM pool for others to trade against, you're a maker.
And a taker.
A taker is someone who executes a trade immediately against that available liquidity. They take liquidity off the board.
Here's where it gets really interesting to me. If you look at the broader landscape of DeFi right now, this era of DeFi 2.0 protocols have become obsessed with inventing the most opaque, dizzying, convoluted fee structures imaginable. It's exhausting.
It really is a maze.
You provide liquidity, but you don't earn the trading fees. Instead, you earn a synthetic receipt token, which you then have to take to a separate gauge and stake it, so you can earn emissions of a completely different governance token. But that token vests over 4 years, and if you withdraw early, you face a 50% slashing penalty. I mean, it literally requires an advanced spreadsheet just to figure out if you are actually making a profit or losing money to inflation.
It is a deliberate obfuscation of yield. Many protocols use those Byzantine tokenomics to hide the fact that the underlying market is fundamentally unprofitable.
Exactly.
CLOA has actively rejected that trend. They chose ultimate simplicity. The taker pays a small percentage fee for the convenience of instant execution. The maker, the person who took the risk of providing capital, earns a direct cut of that fee. And the protocol takes a tiny slice to fund ongoing development.
And does it matter where I put my liquidity? Because earlier we established there are limit orders, constant product pools, and concentrated pools. Do I have to guess which one pays the best yield?
No, and this is a critical design choice. This fee structure applies identically across the entire unified system. Whether you provide liquidity through a precise active limit order or passively through the AMM, the incentive logic remains exactly the same.
That's a relief.
You are directly rewarded for bringing capital to the system. The relationship between users, liquidity providers, and the protocol is transparent and frictionless. You provide a service to the market, and the market pays you for it.
It is a refreshing return to first principles. Okay, so let me take a breath and look at what we've built so far. We've fixed the fragmented aisles of the grocery store. We've smoothed out the math to completely destroy the spread. We've solved the cold start problem. And we've implemented an honest, straightforward economic incentive model.
A very solid foundation.
This is an incredibly strong institutional-grade architecture. But now we have to talk about the elephant in the room. Because even if you build the most perfect, efficient trading engine in the world, if you deploy it on a public blockchain, traders still face a massive, potentially ruinous problem. Let's pivot to the stealth layer, native privacy on a public chain.
If the unified liquidity curve is the mechanical heart of this DEX, the privacy infrastructure is its armor. The true differentiator of CLOAK, the feature that elevates it from a highly efficient DEX to a paradigm-shifting one, is its native integration with the CLOAK Shielded Protocol.
Privacy is such a misunderstood concept in crypto. When you talk to people outside the industry, they think blockchains are inherently anonymous. They think, oh, it's just crypto, it's all dark web stuff. Nobody knows who you are because your name isn't on the account. Just a string of random letters and numbers.
Which is completely false.
The reality of DeFi is the exact terrifying opposite, isn't it?
It is the most hyper-transparent financial system ever constructed. A public blockchain like Ethereum or Telos is an immutable, entirely public ledger. Every single transaction you make, every token balance you hold, the exact timestamp of your trades, the smart contracts you interact with, it's all broadcast globally, permanently, for anyone to analyze.
And the anonymity of that random wallet address doesn't last long. The moment you send funds from a centralized exchange where you did KYC, or the moment you buy an NFT and link it to your Twitter account, your real-world identity is permanently tethered to that string of numbers. Suddenly, your entire financial history is a public spectacle.
I like to use the analogy of a high-stakes poker game. Imagine sitting down at a table in a casino. But instead of holding your cards close to your chest, you are legally required to hold your cards facing outward for the entire table to see.
Oh, wow.
Everyone knows exactly what you are holding. They know exactly how many chips are in your pocket. And because they can see your hand, they can anticipate your next move before you even make it.
And to make the poker analogy even worse, you aren't just playing against other humans, you're playing against supercomputers. In the transparent DeFi ecosystem, institutional traders, whales, and even sophisticated retail users face the dark forest problem.
Yes, The dark forest is a term used to describe the predatory environment of public mempools. When you submit a trade on a transparent blockchain, it doesn't execute instantly. It sits in a waiting area, the mempool, waiting for a miner or validator to package it into a block.
And while it sits in that waiting room, predatory trading bots are scanning it.
Constantly. These bots utilize MEV miner extractable value. If a bot sees that you are about to place a massive $500,000 buy order for a token, the bot knows your order is going to push the price up significantly.
Right.
So the bot pays a slightly higher network fee to essentially bribe the network into processing their buy order milliseconds before yours. The bot buys the token cheap, your massive order executes and pumps the price, and then the bot instantly sells the token back to you at the artificially inflated price.
It's called a sandwich attack. They front run you, and then they back run you. They literally steal value from your trade by exploiting the fact that your financial intent was public information before the trade finalized. It is a massive tax on transparent trading. So how does CLOAK stop the bots? Do they just hide my total balance?
It goes much, much deeper than simply hiding a wallet balance. Privacy on CLOAK is not an external add-on or an afterthought. It is native to the infrastructure. The protocol gives the user a choice.
What's the choice?
If you want, you can use a standard transparent interface like the Anchor wallet and interact with the DEX normally. Your trades will be public. But you also have the option to use the CLOAK wallet for a fully private experience.
So the CLOAK wallet lets me finally turn my poker cards around so they face me.
Exactly. But the critical innovation here is the scope of what is shielded. We're not just talking about private transfers sending money from Alice to Bob quietly.
Yeah.
The DEX workflow itself is shielded. This architecture allows for private limit orders, private trades, private liquidity positions within the AM, and even private fee claims.
Okay, hold on. This is where my brain breaks a little bit. I need to heavily push back on the mechanics here because this sounds like a technical paradox.
That's so.
If my liquidity position is private and my limit order is private, meaning the public blockchain cannot see that I placed a bid to buy $10,000 worth of TLOS at 15 cents, how in the world does the unified execution engine know my order exists? If the engine can't see the order, how does it route a trade against it? You are describing a blind computer successfully playing a game of darts. It feels like magic.
It is not magic. It is cryptography. Specifically, it relies on zero-knowledge infrastructure. Now, we don't need to dive into the dizzying algebraic geometry of ZK snarks to understand how this works conceptually. We can understand the core logic of zero-knowledge proof.
Please give me the explain it like I'm five version of a zero-knowledge proof because it's vital to understanding this DX.
The classic analogy is the Where's Waldo puzzle. Imagine I have a massive, complex picture of a crowd and Waldo is hidden inside it. I want to prove to you that I know exactly where Waldo is, but I absolutely refuse to show you where he is on the map. I want zero knowledge of his location to pass to you.
How do you prove it without pointing at him?
I take a giant, opaque piece of cardboard that is twice the size of the puzzle. I cut a tiny Waldo-sized hole in the very center of the cardboard. Then, behind closed doors, I place the cardboard over the puzzle, aligning the tiny hole perfectly over Waldo.
Okay, I'm with you.
I bring the board out to you. You look through the tiny hole, and you see Waldo.
I see Waldo, so I know mathematically that you found him, but because the cardboard is covering the rest of the map, I have absolutely zero context of where he is relative to the rest of the picture. I don't know his coordinates.
Precisely. You have verified the truth of my claim without learning the underlying data. In the context of the CLOAK DEX, the shielded protocol allows your wallet to generate a cryptographic proof. You are essentially proving to the smart contract engine, I have the capital and I am willing to buy at this specific price, without showing the rest of the world your wallet address or your exact strategic price point.
That is incredible. So the execution engine can process the logic, it can match a buyer and a seller, or flow a trade through a private AMM position because the cryptography guarantees that the state of the market is valid.
Exactly.
The engine knows the math checks out. But to an outside observer or a predatory MEV bot looking at the block explorer, the specific details, who traded, what the strategy is, how deep the private liquidity pool is, remain completely obfuscated.
Yes. The engine executes the trade trustlessly, but the dark forest remains blind to your intent.
This represents a massive paradigm shift for strategy. If you are a professional market maker, you can provide deep liquidity to this exchange without broadcasting your precise spread strategy to your competitors.
That's a huge advantage.
If you are an institutional whale, you can slowly scale into a massive position over several days without causing a market panic or getting front-run by a fleet of sandwich bots. You get all the security, automation, and non-custodial benefits of decentralized finance, but you finally regain the strategic privacy of traditional centralized finance.
It forces us to ask a larger question about the evolution of the space. In a world where radical transparency has been forced upon users as the unavoidable cost of doing business on-chain, the ability to shield execution flows and liquidity positions isn't just a neat feature. It is a fundamental, necessary upgrade to market fairness.
Which brings us to our final major pillar, the engine room. Because to run a complex, hybrid, mathematically unified routing engine and to constantly recalculate the spread to zero and to do all of this while actively calculating and verifying heavy zero-knowledge cryptographic proofs for native privacy, you cannot just build this on a legacy blockchain.
No, absolutely not.
If you try to run this much math on Ethereum mainnet, the network will choke and gas fees will spike to $200 a trade. This entire elegant architecture shatters if the underlying foundation is slow. You need serious horsepower. Let's look at the infrastructure CLOAK chose.
The technical foundation is paramount here. CLOAK chose to build entirely on-chain on the Telos mainnet, which utilizes Antelope infrastructure. There are three specific technical advantages of this network that make the CLOAK architecture mathematically viable: extremely fast finality, negligible transaction costs, and deterministic execution.
Let's break those down, starting with fast finality. In crypto, finality is the moment a transaction is irreversibly permanently etched into the blockchain. On a network like Bitcoin, you might wait 10 minutes for a block and an hour for full finality.
Right.
Even on newer EVM chains, you submit a trade and you watch a little loading spinner for 5 to 10 seconds, hoping the network accepts it and the price hasn't shifted drastically while you wait.
Which is completely unacceptable for a real-time hybrid market. If you are trying to capture a near-zero spread, milliseconds matter. If the market state changes while your transaction is pending, your trade fails or suffers slippage.
So what does Telos offer?
Telos provides half-second block times and almost immediate finality. When the CLOAK execution engine routes your trade between the limit book and the AMM, it happens almost instantly. The state of the market updates globally without lag.
And then there's the cost. Low transaction costs are vital because high fees destroy capital efficiency, especially for retail users. If I have to pay a $20 gas fee just to place a limit order and another $20 to cancel it if I change my mind, I'm never going to use the platform.
Exactly.
Telos keeps the gas cost negligible, which allows market makers to actively manage their positions without bleeding capital to network validators. But it's that third term that I really want to dig into, deterministic execution. That sounds highly technical, but why does it actually matter to me as a trader?
Deterministic execution is the bedrock of complex smart contract reliability. It means that when you submit a transaction, the outcome is highly predictable. The smart contract will execute the logic exactly as coded in the exact sequence it was received, without unexpected variations caused by network congestion or unpredictable miner behavior.
Why does sequence matter so much?
Imagine you have an order that needs to be split. $5,000 goes to a limit order, and the remaining $5,000 flows into the AM curve. You need absolute certainty that the engine will process that logic sequentially and flawlessly every single time.
Right, or the math breaks.
If the network execution environment is chaotic or non-deterministic, the logic could stutter. The AMM math might process before the limit order settles, disrupting the unified curve and creating a microscopic arbitrage window. Deterministic execution guarantees that the massive volume of high-frequency trades won't cause the engine to glitch out.
It's the difference between a finely tuned Swiss watch and a clock made of rubber bands. But here's the detail that I think is the most crucial point of pride in their entire architectural design. We have to talk about what they aren't doing, because there are no off-chain matching engines, there are no centralized relayers, there are no hidden execution layers operating on a private server. Everything, the routing, the matching, the zero-knowledge verification happens fully inside the smart contract, natively on-chain.
This is a vital distinction for the ethos of decentralized finance. Over the last few years, as DEXs have tried to compete with the speed of centralized exchanges like Binance or Coinbase, many protocols have quietly compromised their core principles. They market themselves as decentralized, but in reality, they rely heavily on off-chain infrastructure for the heavy lifting.
It is the ultimate bait and switch. I've used this analogy before, but it perfectly applies here. It's exactly like a trendy new restaurant claiming they bake all their pastries from scratch, artisanally, right there in the kitchen.
I love this analogy.
Right. But if you peek through the swinging doors into the back alley, you catch the staff carrying in mass-produced, store-bought cakes from a delivery truck. These decentralized exchanges are using a centralized Amazon Web Services server to sequence and match the trades, and they only use the blockchain at the very end as a slow settlement receipt layer.
Exactly. And the blockchain is just the waiter bringing you the receipt for a cake you didn't even see them bake. They use off-chain servers for speed because their chosen blockchain isn't capable of handling the matching logic. Or they use relayer centralized third parties to pass messages between the order book and the blockchain,
And why is that dangerous?
because it introduces trust assumptions back into a trustless system. It introduces central points of failure. If that off-chain AWS server goes down, or if the relayer is compromised or decides to censor your transaction, the supposedly decentralized exchange completely stops working. You are no longer interacting with immutable code. You're asking a middleman for permission to trade.
CLOAK's promise is an open kitchen. You see every single ingredient mix on-chain. The Telos network is fast enough, and the Antelope architecture is capable enough that the entire complex matching logic, the hybrid routing tree, and the heavy zero-knowledge privacy shielding all happen within the trustless, immutable environment of the smart contracts themselves. You don't have to trust the server, you only have to trust the code.
It is the original promise of DeFi, finally delivered without the compromises we've been forced to accept for the last 5 years.
We have covered a monumental amount of ground today. We started in the broken, maddeningly fragmented grocery store aisles of traditional DeFi, where users are forced to hunt for liquidity manually. We broke down the mechanical if-then logic of a unified routing engine that hunts for best execution automatically. We explored the deep math of a consolidated liquidity curve that uses continuous AMM algorithms to destroy the dreaded spread.
It's been a journey.
It really has. We looked at how a 15% auction injection solved the lethal cold start problem, and how a simple maker-taker fee model replaces the exhausting tokenomics of DeFi 2.0. We unveiled the paradigm-shifting stealth layer, utilizing zero-knowledge cryptography to protect traders from the dark forest of MEV bots. And finally, we examined the high-performance deterministic Antelope infrastructure, making it all possible without resorting to fake, off-chain decentralization. So as we wrap this up, how would you summarize the ultimate message of the CLOAK architecture?
The ultimate takeaway is that the historical trade-offs we have stubbornly accepted in decentralized finance are no longer mandatory. Kiwalo is attempting to prove that you do not have to choose. Order flow, capital efficiency, liquidity depth, and strategic privacy do not have to be in conflict with one another.
You can have it all.
Yes. You don't have to sacrifice speed for true decentralization, and you don't have to sacrifice your privacy for deep liquidity. They're delivering a single, unified market with intelligent execution and ground-up privacy.
It is a fundamentally different path forward. And the most exciting part for you listening right now is that this isn't just theory anymore. This isn't a 40-page white paper promising a revolution 3 years down the line. The CLOAK TLOS pair is live right now on mainnet. If you are skeptical, if you've heard protocols promise zero slippage before and it turned out to be a marketing gimmick, you can go verify the math yourself. If you want to see what a genuinely unified liquidity model looks like in practice, if you want to observe a near-zero spread ecosystem functioning natively on-chain, you can visit the platform at app.cloak.todayandadvanced.network, TLOS-mainnet. Go explore the market, watch the order book fluidly, talk to the AMM, and see what the future of execution actually feels like.
It is a remarkable piece of engineering that demands attention. But before we finish, I want to leave you with a final lingering thought to ponder regarding the broader industry. If CLOAK's model of hybrid, private, and fully on-chain trading works at scale, if it empirically proves that we don't need fragmented pools and becomes the new, highly efficient standard for the Antelope ecosystem and beyond, what happens to the massive multi-billion-dollar transparent fragmented DEXs that currently dominate the market? Will these legacy giants be forced to radically adapt, halting their operations to rebuild their entire architectures from scratch? Or will they simply be outpaced, eventually seen by future traders as the clunky, dangerously transparent, inefficient relics of DeFi's version 1.0?
That is the multi-billion-dollar question. In this space, technology moves at breakneck speed, and the untouchable giants of today could very well become the dinosaurs of tomorrow if they refuse to adapt to a better foundation. Thank you so much for joining us on this deep dive into the architecture of the CLOA Hybrid DEX. Keep questioning the systems you use, keep demanding better execution, and keep exploring the frontiers of decentralized finance.